Hi there. So in this video, we're going to look at reducing radicals. We'll be focusing primarily on square roots. However, just to give you a little bit of background information here, the symbol that you see here is referred to as a radical in mathematics. The expression under the radical is referred to as the radicand. And if there's a number outside acting as a superscript of that radical, it's referred to as the index. If you don't have a number outside of your radical, then we assume it to be like an imaginary 2. So it's kind of like this, that if you don't have a number sitting out there, we assume that there's a little imaginary 2 there. And therefore, so if you're just sitting here with without that little 2 there, then you're essentially they're both the same and you're referring to the square root. In fact, just below that, the square root of a number, as you may know, is a value that when it is multiplied times itself, you arrive at that number. So the example that I'm giving you here then is the square root of 4. Hopefully you would agree. The square root of 4 could be rewritten as the same as the square root of 2 times 2. So then, therefore, if 4 is the same as 2 times 2, then the square root of 4 is just 2, because I can now take 2 and multiply it times itself and get that 4. So that we say then ultimately that the square root of 4 then is 2. So we'll start here with just looking at perfect square roots. So perfect square roots, again, you're looking for a number that when you multiply it times itself, you arrive at the number underneath the radical. So 16, you're asking yourself, what can you multiply times itself to get 16? And so you're sitting here thinking, hopefully, oh, okay, well, I know that that's square root of 16. That's the same as 4 times 4. So therefore, then, the square root of 16 is 4. And you may not, and you hopefully won't even need to write this step here, but I'm just sort of showing you a little bit of behind the scenes that's going on. The square root of 36 then, okay, what can we multiply times itself to get 36? I hope you would agree. That's 6. Move on just to do 2 more with you. Square root of 25. What can you multiply times itself to get 25? Hopefully you agree with 5. And then lastly here in letter D, square root of 100. What can you multiply times itself to get 100? And hopefully you also agree there would be 10. I encourage you now to pause the video, try E through H, make sure that you're tracking. You've got the solution key there in Blackboard to check yourself by. All right, so I'm going to move on now, and we've just looked at calculating perfect square roots. Now let's generate a list of values that we know that we're always going to be able to take the perfect square root of. So, for example, 2 squared we know is 4, 3 squared is 9, 4 squared is 16. So all of the numbers over here on the right are values that we can take the perfect square root of, right? Because we know the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so on. I stopped my list here at 12, but we could continue on. I mean, I could do 13 squared, that's 169, 14 squared, and so on. The list here is essentially infinite, okay? So we're going to be utilizing this list and mainly these numbers over here on the right-hand side to reduce square roots that are not perfect. So if we flip it on over, I listed for you at the top those numbers that were on the right-hand side. So these are your perfect squares. These are numbers that you can take the perfect square root of, right? Because we know the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and so on. Again, I stopped my list here at 144, but you know I put a dot, dot, dot. It continues on. So now we want to be able to advance in order to be able to reduce radicals that that are not perfect square roots, but they will involve a perfect square root. So I have listed for you here the steps that you will do. Instead of me reading those to you, I'm just going to demonstrate that to you. So what your goal will be is, for example, if you wanted to reduce the square root of 48, and of course I've already showed that work here, but I'm gonna talk you through it. So the square root of 48. The goal is, and I'm going by these steps up here at the top, you look for the highest number in this list up here that I've got highlighted. You look for the highest number in this list that will divide evenly into 48. Okay, so you might say, well, hey, I know 4 goes into 48. It can, but always browse and see if you can go a little bit higher. Of course, it could never be any number higher than 48. So here we know it has to be one of these numbers or less. It has to be from 36 down. 16 will also go into 48. So I'm actually going to show it with the highest one first. I'm going to show this problem 2 ways, but I'm going to show it with the highest one first so you can see how you can get there in one step. But I will also show it in case you ever don't pick the highest number. Just want to make sure how you know when to stop, okay? So we have the square root of 48. we look at the highest number in this list that will divide evenly into 48. That's 16. And now you ask yourself, 16 times what gives you 48? That's 16 times 3. Now, whatever number that you can take the square root of that's underneath the radical here, you do so and pull that outside of the radical. So the square root of 16 is 4, and then you leave the 3 inside because you can't take the square root of it. You know that you can stop at this point because when you look at this 3 underneath the radical, you ask yourself, is there a number in your list that will divide evenly into 3? And definitely not. So that's your final answer. Okay, so that's how we know to stop. Let's say, for example, you did it a different way and you said, well, hey, I know a number in my list that'll go evenly into 48 is 4. And you're absolutely right. And so you ask yourself, okay, well, now 4 times what gives you 48? That would be 4 times 12. So now we reduce. We know the square root of 4 is 2. So whatever you take the square root of, that comes outside. And you leave the other number inside. But you still ask yourself, okay, you've got this 12 left over. Is there a number in my list that will divide evenly into 12? And sure enough, 4 will go into that number again. So I'm going to reduce again. So I can rewrite 12 as the same as 4 times 3. Now the square root of 4 is 2. Multiply it times the 2 that's already sitting out here. And so 2 times 2 is 4. Square root of 3. Again, it's easiest if you go with the highest number first, but I wanted to let you know that if you don't pick that highest number, always be on the lookout to make sure that your final answer is reduced to lowest possible terms. And here, whenever we picked our 4 underneath the radical, we were still left with a 12, and there's still a number in our list that can go into 12, so I can't stop there. Okay, so now let's do a couple more. So now if we move on down here to example 2, it just says reduce each radical. Again, you always want to keep this list here in your back pocket, thinking about that list up here. So you're looking for the highest number in that list that will divide evenly into the given number. So with 72, hopefully you would agree with, okay, well, 36 will go into that. 72. 36 times what gives you 72? 36 times 2. So at that first stage, all that you're doing is picking the highest number in your list that will multiply to give you that number, and then then that number times what gives you this. So 72 is the same as 36 times 2. Now from here, let's reduce. The square root of 36 is 6, so it comes outside, and the 2 stays inside. Final answer. All right, we move on over to 66, the square root of 66. So we look for the highest number in our list that will divide evenly into 66. And essentially, if you're not good with your multiplication tables, you just take out a calculator and you start going through the list. 66 divided by 4. Oh, that's not an even number, right? 66 divided by 9. That's not an even number. And I mean, the farthest you can go up is 64, because remember, it has to divide evenly into it. So if you can't find a number in your list, which in this case you're not going to be able to, this would be an example of something that is already simplified. You can't break it down any further. Okay. All right, let's move on over to letter C here. In letter C, I have the square root of 56. So I'm looking for the highest number in my list that will divide evenly into 56. And so we would do 56 divided by 4. Okay, that works, right? 4 times then 14 gives me 56. Square root of 4 is 2, so it comes outside. 14 stays inside. And you might think, well, 14 is a large number, but you ask yourself, is there a number in your list that will go into 14? And when I'm referring to this number in my list, but the number in my list are my perfect squares, and so no. So that's my final answer. All right, let's move on to letter D, the square root of 400. Some of you may recognize that the square root of 400 actually is a perfect square, and you could go ahead and answer it and say, okay, this is 20. But if you don't recognize that, then you can still use the list method that I've got up here. You ask yourself, okay, what's the highest number in this list that will go evenly into 400? And since it's 100, then you should recognize that, okay, well, 400 is the same as 100 times 4. But here now you'll notice that both of these numbers are perfect square roots. So they're both going to come outside of the radical. The square root of 100 is 10. The square root of 4 is 2, and then 10 times 2 will arrive you at 20, okay? All right, I'm going to leave the rest of this page here for you. If you have any questions, feel free to reach out to me. And be sure you can check yourself by the solution key. Thanks a lot. Bye.